Hey guys, today we're doing section 1.4. Section 1.4 deals with comparing rational and irrational numbers with each other. I have this little example we're going to start with. Let me read it. For people who prefer pizza, the Lasagna Shack offers thin crust pizza in 3 different shapes. Each one costs $20. Which deal is the best and which is the worst? If you want to try to figure it out, then come back to the video, go for it. I'm going to explain it now. Let me put a few things on the board. Alright, so what I've done there is I have calculated the area of pizza for each shape. The circle, I used the formula pi times the radius squared. Since the diameter was 18, I knew that the radius must be 9. So I did 3.14 times 9 squared and got 255 square inches of pizza. The square, I used the formula the area is equal to the side length squared. That would be 16 squared or 256 square inches of pizza. And for the rectangle, I found the area by doing length times width, and that gave me 264 square inches of pizza. So obviously, the best deal was the rectangle because it gave you the most pizza. It gave you the biggest area of pizza for the same $20. And the worst deal was, the worst deal was the circle because it gave you the least amount of pizza, only 255 square inches for the same $20. But I have a better question. My better question is, which amount is an irrational number? Which amount is an irrational number? Well, I hope you recognize that the irrational number is the circle. All right? Pi is one of our irrational numbers, the non-repeating, non-terminating decimals. And once you have an irrational number inside a calculation, all the calculations are irrational. So I approximated the area to be 255, but actually it's a non-terminating, non-repeating decimal. So this brings me to my point. Sometimes we need to be able to compare irrational numbers with rational numbers and determine which one's bigger. And that is what this section is all about. It's about comparing or putting in order rational and irrational numbers. Probably not too difficult. Let's see what we have to do. All right, I claim that all numbers can be located on a number line. This means that all rational and irrational numbers can be put on the number line. So, if you can put numbers on a number line, you can certainly put them in order from smallest to greatest. I think we all know that on a number line, as you move to the right, the numbers get bigger. So what I would like to do is, first I'd like to look at these numbers and decide which ones are rational and which ones are irrational. And I'm just going to take them from left to right. So negative 4.5, would that be a rational number or an irrational number? Well, that's a terminating decimal, therefore it can be made into a fraction. It's rational. Negative 11/3. Well, that thing's a fraction, so it must be rational, right? That's the definition of rational. You can make it into a fraction. Negative 11/3 is a rational number. I think that would be a repeating decimal. How about negative the square root of 6? Don't let the negative throw you. This is just whatever the square root of 6 is, but I want negative the square root of 6. So I know that 6 is not a perfect square. Therefore, its square root is irrational. It's a non-terminating, non-repeating decimal. That brings me to the square root of 3. The square root of 3 is also not a perfect square, so its square root is also irrational. Brings me to 1/3. 1/3 is a fraction, so by definition, it's a rational number. It would be a repeating decimal. Brings me to the square root of 2. Again, 2 is not a perfect square, so its square root is irrational. The square root of 11, also not a perfect square, so its square root is a non-repeating, non-terminating decimal. And last up, I have this crazy thing. This is one of those patterns, but it's not a repeating pattern. It's got 1, 1, then 0, then 1, 1, 1, then 0. This would be a irrational number because it's a non-terminating, non-repeating decimal. Good enough. All right. So this is what we're going to be doing kind of for homework. We're going to be taking rational and irrational numbers and putting them in order to determine which ones are bigger and which ones are smaller. Let's see how we're going to do this. I think the best way to compare rational and irrational numbers is to write them in the same format. And I think changing them into decimals is the best way to go. And we're going to practice for a minute doing changing each of them into decimals and having them go 2 decimal spots. Generally, that is enough. The other thing is once you get them put into decimals, you're going to want to compare them from left to right until one of them is bigger. I have one more thing to say about this, and that is negative numbers. negative numbers are often a source of confusion. Remember that with negative numbers, like -6 and -4, the bigger the negative number, the smaller its value, right? So when you're comparing two numbers, if a negative number is bigger, it's actually got a smaller value. Think about temperature. A temperature of -6 degrees would be a lower temperature than a temperature of -4 degrees. -6 is a lower number than -4. All right, let's practice real quick changing different types of numbers into decimals so they can be easily compared. I think a helpful hint is to write the decimal to the same number of decimal places. I think 2 places is a good place to start, but it doesn't always have to be 2 places. Sometimes that is too many, and sometimes it's not enough. For decimals that do not go to 2 places, you're going to need to add zeros at the end. For a terminating decimal, you can add zeros at the end without changing the value of the decimal. For decimals that go more than 2 places, like ones that are terminating but they have like 3 or 4 spots, or repeating decimals that go on, or irrationals, which are decimals that are non-terminating, you will have to cut them off at 2 places. Notice I said cut them off, not round them. When you round a decimal, you change its value. We don't want to change its value. So we're just going to cut off the decimal if it goes more than 2 spots. Let's do a couple examples. The first example is a terminating decimal, 1.7. I want it to go 2 spots. So to make it go 2 spots, I'm just going to throw a 0 on the end. The next decimal is 1.7 repeating. So that one, would be 1.7777. I'm just going to cut it off after 2 spots. Notice, by the way, that the decimal 1.7 repeating is actually a bigger number than 1.7 that terminates, because 1.77 is bigger than just 1.70. All right, the square root of 5. I would need to type that into my calculator. Take the square root of 5. My calculator says it's 2.231, and it keeps going. It's an irrational number. So I'm just going to cut it off at 2 decimal places. That would be 2.23. The next number I have is also irrational. I'm just going to cut it off at 2 decimal places, and it would be 1.28. Next, I have a fraction. I have 5/3. I'm going to take 5/3 and change it into a decimal. That'd be 5 divided by 3. And I get 1.6666. It's a repeating decimal. So I'm going to cut it off after 2 spots, 1.66. And last, I have 1 3/5. So I'm going to change the 3/5 into a decimal on my calculator. I get 3 divided by 5, that would be 1.6. It's a terminating decimal, but I want it to go 2 decimal places, so I'm going to add a 0 on the end. All right, that is just a little practice, how to change any number into a decimal and write it the same number of spots. I will do part 2 with the examples on the next video. Good luck. All right, this is part 2 of section 1.4. We're going to go through the examples. I have them on the board. So I want to complete each statement with less than, greater than, or equal to. Right? If you want to try turning off the video and doing it yourself first and then flip it back on and see how you did, it's a good way to practice. Remember that this symbol here, most people consider this to be like a Pac-Man or an alligator's mouth, and the open mouth side is always open to the bigger amount. So if you have trouble remembering which one is less than and which one is greater than, the mouth always eats the bigger number. Put the bigger number in front of its mouth. All right, to compare these, I am going to make each of them a decimal, and for these, I'm going to have them go one spot instead of two like I did before. So I type the square root of 3 into my calculator, and it turns out to be 1.1. And of course, the number 1 is 1.0. So clearly 1.1 is bigger than 1.0, and that would be the correct symbol. In the second example, 1.5 is already done. I would type in the square root of 2 to my calculator and find out it's 1.4 blah blah blah. 1.5 is the bigger number, and that symbol would go in. In letter C, the 3, if I made it go one decimal place, I would add a 0 after the decimal. It would be 3.0. The square root of 12, I type it into my calculator. I find out it's 3.4. And so 3.4, the 3's tied, but 4 is bigger than 0. Goes that way. Maybe you knew that was bigger because the square root of 9 would be 3, and since this is bigger than the square root of 9, it must be bigger. Letter D, 20 over 9. I type that into my calculator, 20 divided by 9, and I get 2.2. The square root of 6, the square root of 4 is 2. This is a little bit bigger than 2. I wonder if it's going to be bigger. Let me type it into my calculator. Turns out to be 2.4, and so the square root of 6 is greater than 20 over 9. All right, letter E. I have negative numbers. When I type the square root of 7 into my calculator, I find out that it is 2.6. And now I want the negative square root of 7, so it'd be negative 2.6. And of course, this is also 2.6. So these seem like they're equal. But they're not, right? I just need to go another decimal place. This is one of them where one decimal place was not enough. So I go back and I look at my calculator for the square root of 7, and I find out it's 2.64 when I go 2 decimal places. Whereas the terminating decimal, 2.6, if I want to go another decimal place with that, I would be just adding on a 0. So actually, one of them is negative 2.64, and one of them is negative 2.60. Which one's bigger? Well, you want to remember, with negative numbers, the bigger the negative number, the smaller its actual value. So this would be the correct sign. Negative 2.64 is a smaller value than negative 2.6. And last up, I have letter F, pi to the second power. I type that into my calculator. I find out it's about 9.8. And 9.8 is bigger than 9.5, so that would be the correct value. Let me just show you a couple more things. You'll have a problem like this on your assignment. You are planning an art exhibit. One of the artists, of course, is a former math teacher, because math teachers are known as great artists. Each artist sent you the heights of their paintings. You want to display the paintings from shortest to tallest. So let's see. I need to take these numbers and put them in order from smallest to biggest. Again, I think I'm going to type them each into my calculator and go one decimal place. typed in the square root of 2 and I cut it off after 1 decimal place, with a whole number 2, I added a 0 after the decimal, so it could go 1 decimal place. I think that's pretty much it. Now I need smallest to biggest. So certainly I'm going to start with the ones that are 1 point something because they are smaller than 2 point something. And it looks like 1.4 is the smallest. So the square root of 2 is the smallest number up here. And 1.6 is next. Then I get to the 2's. It looks like 2.0 would be next. Then 2.2. Then 2.6. And then 2.8. And the one thing I ask is that you write the original number, and I did not do that on one of these. Where is it? 2.2. This should be the square root of 5. I have now put the original numbers in order from smallest to biggest. One more example, and we're going to be done. This one's interesting because it's got some negative numbers in it. Let me start by going through and rounding each of these to 1 decimal place. Okay, so this one's interesting because it's got the negative numbers, and I want to review negative numbers real quickly. Let's look at a number line here. And let's put these negative numbers on the number line. So I start with this one, negative 4.2, that'd be negative 1, negative 2, negative 3, negative 4, negative 4.2. Might be about right there. And we'll do this one, negative 4.1. Negative 1, negative 2, negative 3, negative 4, negative 4.1 might be about right there. And last up, negative 1.7. So that'd be negative 1, negative 1.7 might be about right there. I just want to reinforce the idea that as we go this way, numbers get smaller. And clearly, the red dot, the negative 17/4, is the smallest number of these. It looks like it might be the biggest, 4.2, 4.1, but remember, as negative numbers get bigger, their value actually gets smaller. One more thing. Make sure you pay attention to the directions. In this case, I'm going from greatest to least. So let's start that. Looks like the biggest number up here would be, well, it'd be a positive number, right? I'm only going to choose from the 3 positive numbers. That one looks like the biggest number, 3. Then 1.6. Then 1.1. All right? And now I work down to the negatives. This is the next biggest number, negative 1.7. This is the next biggest number, negative square root of 17, and the smallest number is negative 17/4. Good, so practice with negatives. I know there's one more example. We're going to leave this example for a class discussion. I did make a little mistake here. I forgot to complete the square root sign there. You might want to throw a little square root sign above the A. Hope that helps. Good luck.